In this video, you and I get to walk through the logic and integration of our lab environment and connect it up to the live public internet. And as a quick recap of our design, we're talking about this device right here. So this device, which will act as a router as well as performing address translation, will have one interface connected into our 23.1.2 network with an IP address of .1, and the other side is going to connect into my home office network and allow connectivity. So the end game is, once we have everything configured, is that devices over here in our lab environment, like PCs behind firewall 2 or behind firewall 3 or directly on this 10.123 network, our goal is to have that traffic being allowed out to the public internet, which would involve one of these 3 firewalls doing our local network address translation. And in addition, having our NAT PAT device here do the translation from the 23 address space also out to the public internet. Now, one aspect to be aware of as well is that this address space, the 23.1.2, which we're building in our lab environment, that is actually public IP address space. However, we don't want to source any packets from 23.1.2 in the real internet, because if they try to respond back, they're going to be going back to the real servers. And that's the benefit of having this additional NAT/PAT device here that can be trained that any traffic that's coming from the 23.1.2 address space should be, again, NATed/PATed and address translated before it's sent out to the public internet. So once that's in place, we can then pretend that firewall 1 is connected to the public internet, and just realizing behind the scenes that we have this NAT/PAT device doing additional translation to make it all possible. So in my lab environment, I've got a few options, and I'm probably most familiar with Cisco. I happen to be a double CCIE with Cisco systems, and so I've got a virtual version of a Cisco router right here that we're going to place and then configure it to perform address translation between our lab network and the public internet. And I'll walk you through those steps right now. So here's our topology in EVE-NG. Let's right click and we'll add yet another node by clicking on node. And I'm going to go ahead and grab a Cisco iOS router. Now I have a couple options here. In fact, any router will do in a storm, right? So let me just grab this one. I'll call it R1. Scroll down and click on save. And again, if you're familiar with Juniper or HP or some other vendor and you want to use that product for address translation, feel free to do it if you have that integrated as part of your EVE-NG. So let's connect R1 to this network by dragging and dropping. And let's go ahead and use 0/1. Click on save. So then we need another network that represents the other side of this PAT/NAT device that leads out to the internet. So to do that, we'll right click from the drop down, we'll click on network, and I'm going to go ahead and choose management, which represents on my local network, my management network. And I'll change the icon there to represent a cloud. And I'm simply going to rename this internet, or at least the network that leads off to the internet, and click on save. All right, and then we'll connect our router to that. And I'm going to use E00 as the interface connecting out to the public internet. So here's our game plan. On this router, R1, we're going to specify Ethernet 0/1 has the IP address of .1. And then on this interface, E00, we'll have it be a DHCP client. And then regarding address translation, we can set up port address translation, where any incoming packets, if they're sourced from 23.1.2 anything, this device can go ahead and overload them to whatever the IP address it got assigned on its E00 interface. That'd probably be the simplest configuration for address translation on this device. So once we have that in place and we save it, then in the future, any traffic that we need to go out from like PC2 or PC3 as it's being forwarded out to the public internet, we can have these edge devices like Firewall 1 do address translation and swap out the address to the IP address on port 4 with its own flavor of PAT, or we can make a pool of addresses right here on the 23.1.2 network and use that pool of addresses for address translation. However, for any of that to work, we need to have this device right here in play. So let me walk you through the steps on this router, R1, with 0/1 being the inside interface and 00 being the outside interface. And let me walk you through the basic configuration of this Cisco iOS router, who's doing that address translation for us. So in EVE-NG, to get to the console of this device, this router, we'll simply click on it. So I have my EVE-NG configured to open up Secure CRT for a terminal. And let's go ahead and configure R1. So here on the Cisco router, we use the command configure space terminal, which the shortcut is config space T. And I'm going to use the hostname command. Let's call this R1. Then we'll go to interface E0/1 and give the IP address of 23.1.2.1 with a 24-bit mask. And we'll do a no shutdown just to make sure it's up. And then we'll go to interface 0/0. And it's going to be a DHCP client. So we'll use the command IP address DHCP. And in the background, it looks like he was trying to TFTP to the broadcast address looking for some type of config, specifically a file called network config. And that timed out, and then it's trying to look for a file called cisconet.cfg. And there we have a message right there that just got an IP address on its 00 interface of .15. So we'll exit out of interface configuration mode. And to train this router that it should do address translation for everything from the 23.1.2 address space, we're going to create an access control list. And one way of doing that is with this command, access list. We'll call it access list number 1. And we'll say permit traffic from 23.1.2. anything. And the way that you do that with a Cisco ACL is you say 000 for the first 3 octets which you want to match on, and then a 255 for the final octet that you don't care about. And then we're going to use that access control list as part of our address translation rule. With the command IP NAT inside source, and we're going to point to that list of list number 1, and we'll say if traffic does match 23.1.2, go ahead and translate to the IP address on interface Ethernet 0/0, and also be willing to do that for multiple addresses. And so we use the keyword overload to implement that. And then we need to tell the 2 interfaces which one's inside from a NAT perspective and which one's outside. So we'll go to interface Ethernet 0/0, and we'll say IP NAT outside, and then we'll go to interface Ethernet 0/1, and we'll say IP NAT inside. So on this router, if we do a show IP route, I just want to verify I have a default route, which I learned via DHCP. Great. And that is my default gateway on my home office network. So if we do a ping to 8888, ruh-roh, that's not working. Why is that? Let me go ahead and try that one more time. Okay. So in the background, I've got a few other security appliances involved in that decision to let traffic go through. But it appears to be successful now. That's great. And also, if we want to verify that this device truly can translate from the 23.1.2 address space going out, we could do this. We could do a ping to 8888. Then we could source it from 23.1.2.1, which is our IP address on Ethernet 0/1. And if this works, that implies that address translation is working. That looks good. Show IP NAT translations. All right. And the translation is working. So if the source addresses look like they're coming from 23.1.2 anything, and if Firewall 1 is using R1 as its default gateway, then traffic from PC2, for example, as it goes through the network, can be translated here at Firewall 1 based on the rules that we'll put in place, and then forwarded to R1, who will also do address translation. In this case, it's doing port address translation before it forwards that traffic on to the next hop in the path going out to the internet. So now that we have R1 that can perform some address translation for us, the best way to test our lab and just make sure that we have those pieces in place and that they work is to test it. So in the next video, I'd like to walk you through the testing of traffic from Firewall 1 going out to the internet and verify that reply traffic can come back in. So we'll do that in the next video. I'll see you there in just a moment. Meanwhile, I hope this has been informative for you, and I'd like to thank you for viewing.